on which interval with x greater than or equal to 0 is f of x increasing given that f of x equals x to the 2/3 times x minus 3. Okay? Okay. So increasing means slope. Slope greater than or equal to 0. And so what we're going to do is find the derivative. Whenever you think slope, you should think derivative. So here we're going to have f of x equals x. I'm going to call this x to the first. No, I'm going to call that x3 over 3, which is the same as first. And then that will give us x to the 5/3 minus 3x to the 2/3. We could try and do the product rule with that, and it would totally work. It's just, I think it's easier probably this way. F prime of x equals x. Okay, so we want to take this. So we take this number down. So x to the 5/3, then we minus 1, so it'll be back down to 2/3 again. Minus 3 times 2/3, x to the negative 1/3. So the mnemonic I use for the power rule is you have something to the derivative of x to the n. That little 1 up there is a apostrophe, so it means derivative. So then what I do is I think, all right, n goes down there, so you have n x to the n minus 1. And as you took it down, there's 1 less. That's just the mnemonic of visually how I do the power rule. Okay. I already used blue. I hate it when I use my favorite color first. Everything is kind of a letdown after that. Okay. So simplify this a little bit, make it look prettier. Not that pretty is everything, but you know. Being pretty is nice. So I'm told. Minus 2x to the negative 1/3. Okay? Now from here, what are we going to do? What are we going to do? Okay, we're going to set this. We know that this is going to be greater than or equal to 0, because that means increasing. Yes, I'm going to go with this. So there's 2 ways I'm thinking about going for it. One would be you draw up a table like this, and then you have your, it's greater than or equal to 0, so we put 0 here, and then we do our critical points, and we find on each side of it how it worked. But we could also just say that, all right, we have our derivative. We want the derivative to be greater than 0, because that's what it means for increasing. I say greater than or equal to because generally increasing means greater than, it's either flat or a positive slope. When you hear the phrase strictly increasing, that generally means, okay, it has to only go up, can't go flat. Can't be horizontal. Okay, so math skills, don't fail me now. No, it feels like I'm failing. 2x 1 over x to the 1/3. Still have x to the 2/3 over here. Okay. And then we'll move these over here. So I have multiply both sides by x to the 1/3, x to the 1/3. No. Negative 1/3? Negative 1/3. So I should have, wait a sec. Yep, we'll just multiply the top by x to the 1/3. There we go, like that. So messy. I need to clean this up a little bit. Okay, so moving the x to the 1/3 over here, 3/5 over that side, we're going to get x to the 3 over 3, which will equal x, which will be greater than or equal to 3 times 2, which is 6, divided by 6/5. So we get x is greater than or equal to 6/5. So if we did this by looking for critical points, what we'd do is we would have found, the derivative equal to 0, and we would have found that 6/5 was a critical point. And that would give us 0 for the derivative, or we'd set the derivative equals 0, we'd find 6/5. And from there then, we could plug in numbers from the derivative right here to see which sides are positive and negative. That looks like a lot of work. Let's try it once just to see how it would work though. So we found that f prime of x equals 5/3 x to the 2/3 minus 2 over x to the 1/3. And so if we plugged in, let's say, 1/8, f prime of 1/8, then we could say that, let's see here, 1/8, 2/3, 2/3 minus 2 over 1/8. So I'll write 1/8 reciprocal like this because 1 over 1/8 would just be 8. And then this will be to the 1/3 to the 1/3. You could also just do this in your calculator. So then we'd have 5/3. So 1 to the 2/3 will just be 1. Now 8 to the 2/3, the easiest way to do this is probably to look at this as 8 to the cube root, which we know the reason I chose 1/8. You're like, wow, why'd you choose 1/8? It's because it's between 0 and 6/5. And I know that it's a cube. We know I know I can find the cube root of 8. Therefore, I can find the cube root of 1/8, which is just 1/2. Probably should have explained that earlier before I went down this line. So that's why I chose 1/8. So if you take 1/8 here, you cube root, you get 2, you square 2 and you get 4 minus, and then this will be 2 to the cube root of 8, which will be 2. So we'll be left with 5 over 5/12 minus 4, which is less than 0, therefore decreasing. So this section here would be decreasing from 0 to 6/5. Then I'll choose another number up here. I'll say 8, because we're already proven to ourselves that we can take the cube root of 8. Oh, I'll use a different color than green. Purple? Nope, already used purple. Light blue it is. So they have 5/3. So 8 to the 2/3 power, again, cube root of 8 is 2. 2 squared is 4 minus 2 divided by, so we have the cube root of 8, which would be 2. So we'll have 20 over 3 minus 1, which is 17 over 3, which is positive. So as we already found here, when x is greater than or equal to 6/5, it'll be increasing. So we have this one right here. 6/5 to infinity, non-inclusive. At least, interesting. So it is increasing from, so it's kind of ambiguous if it's actually considered increasing or not at 6/5 because it's flat. But here in the answer they have non-inclusive, so it's just non-issue. 6/5 is not actually counted. Yeah, kind of cool. Okay, so that's how you do increasing versus decreasing. To backtrack, big picture, you write your equation out, you take the derivative. If it's increasing, you find out when that derivative is greater than or equal to 0, which can be tricky with the when you get multiple roots, but this one wasn't too bad. If it gets a little bit challenging or difficult to conceptualize, you just draw out a table. Here's x, here's f of x, here's f prime of x, here's your critical point, and then you plug in numbers on each side of the critical point to find decreasing or increasing. And that's how we solve this sort of increasing, decreasing type function.